Hello, boys and girls. Are you fine at home? Today, I have prepared geometry for you. Geometry is where you draw, you construct triangles, where you construct quadrilaterals, where you measure angles, where you identify properties of angles, and the like. And so today I have selected some Kcpe questions from past Kcpe papers. Boys and girls, I would like you to take note of how we are revising these Kcpe papers for you to be able to revise on your own and master and get acquainted to the Kcpe examination questions. Welcome to today's lesson. Now, in Kcpe 2012, I've decided to begin with 2012. Question number 9. In the figure below, line AB and CD are parallel. Line EF is a transversal. Which are these lines AB and CD? A line is named after the endpoints of that line. So this line starts at A and ends at B. So it's called line AB because it starts at A and ends at B. This line is called CD because it starts at point C and ends at point D. So those two lines are parallel. And how do we know that they are parallel? We know that they are parallel by observing the marks on the line. This arrow and that arrow indicate that the lines are parallel. The lines are parallel. The arrows are put there because the lines are not drawn to scale. And so they are put there to indicate that they are parallel. Then line EF starts at E and ends at F. It's called a transversal line. Allow me to name it transversal. Transversal line. Transversal line. It transverses between two lines. Now, which one of the following choices contains equal angles? Which one of the following choices contains equal angles? Now, I want us to learn some things here. I will write here, I'll write here and there. So let me begin by writing there. There is what you call opposites vertically. Opposite angles. Vertically opposite angles. How do you identify vertically opposite angles? Yeah? They face one another. They are situated opposite to one another. For example, angle G and angle C. Look at their location. They face one another. One is opposite the other. Across the intersection point is here. So these two angles are opposite. So angle G and angle C are vertically opposite angles. Still at the same point, angle F and angle H are opposite. F and H are opposite. They are vertically opposite. All right? Let's go to this other point. Angle D or B and angle D. They are opposite, vertically opposite. B and D are vertically opposite. Likewise, angle A and angle C are vertically opposite. A and C are vertically opposite. So that is how we identify vertically opposite angles. What is it that is so special about vertically opposite angles? Each pair of vertically opposite angles contains of angles that are equal. Vertically opposite angles are equal. Vertically opposite angles are equal. They measure the same. They are equal. What does that tell us, boys and girls? That G is equals to C. G is equals to C. This G measures the same as C. F is equals to H. This F has the same measurements with H. Angle B is equals to angle D. This angle B has the same measurements with angle D. Angle A is equals to angle C. The measurements of angle A are the same as the measurements of angle C. And so, vertically opposite angles are equal. Vertically opposite angles are equal. Each pair contains of equal angles. That is one. Point number one. That is one. Boys and girls. Now, let's look at another aspect. Corresponding angles. Point number two. Corresponding. Angles. Corresponding angles. How do we identify corresponding angles? Now, back to our diagram. Corresponding angles. Let's begin with A. A corresponds with H. Look at that. A corresponds with H. That's corresponding. So, A corresponds with H. A corresponds with H. That means A is equal to H. We understand that? Still at the same point. D corresponds with C. Alright? So, angle D or C is equal to angle D. We understand that? They are corresponding. Look at how they are situated. Be very careful. Remember that there has to be parallel lines and the transversal line to get these corresponding angles. Are we together? Now, let's look at angle B for boy. B, let me use a different pen. Angle D corresponds with angle G. Are we there? Angle B corresponds with angle G. So B and G are equal. Yes? Now, angle C corresponds with angle F. Angle C corresponds with angle F. So, angle C is equals to angle F. Are we together? Is it C? Yeah? C and F. We say the C and, sorry, that was not C and D. It's C. Naming E, sorry, boys and girls, the naming of the angles. Let me confirm from 2012, boys and girls. Let me confirm. It was question number 9, 2012. That is E. Sorry for that. That is angle E. This one is E. That is angle E. So it's E and D. It is E and D. That is E and D. Sorry for that hitch. But well, all the same, you have understood that A and H are corresponding angles, and so they are equal. A and H corresponding. E and D are corresponding, so they are equal. Yes? Follow the arrows. B and G are corresponding, and so they are equal. And then C and F are corresponding, and so they are equal. That means corresponding angles are equal. Let's come to another set of pairs of angles that are equal, boys and girls. Number 3, we are talking about alternate angles. Alternate angles. Alternate angles are equal. Alternate angles are equal. Let's find out how alternate angles look like. Yes? Alternate angles would be angles across a transversal. I always call them angles across a transversal. So C alternates with H. C alternates with H. Are we together, boys and girls? So that means C is equal to angle H. Hope you understand. Another pair that contains alternate angles, it's B and E. B and E, look at that. B and E are alternate angles, and so they are equal. B and E are alternate angles, and so they are equal. Boys and girls, I cannot trace any other alternate angles from that particular diagram. What do we know now about the angle properties, where there are two parallel lines and a transversal line? We now know that we have vertically opposite angles that are equal. We now know that corresponding angles are equal. And we also know that alternate angles are equal. Having known that, gathered that knowledge, we can be able to answer this question. Which one of the following choices contains equal angles? Now, choice A talks of A and E. Angle A and E. Let's look at angle A and angle E. Angle A is this angle here. From the pairs we have seen, angle A is only equal. Let's look at that. Angle A is only equal to angle C because they are vertically opposite. Angle A is equal to angle H because they are corresponding. And angle A is equal to angle F because F is equal to H, which is equal to C, which is equal to A. I hope you are understanding. Now look here. So A is equal to C, which is equal to H, which is equal to F, and which is equal to C. We have already read C. So A could be equal to C, equal to H, and equal to F. So A cannot be equal to E. So A is out. Let's come to C. They're saying C is equals to G. C can only be equal to H, which is equal to F, which is equals to A. So this one is out. B is equals to F. Let's see. B, they're saying B is equals to F. It is impossible. Let's see what B is equals to. B is equals to D because they are vertically opposite. B is also equal to G because they are corresponding. B is equals to E because they are alternate. Are we together? B is equals to D because they are opposite. Is opposite. B is equals to G because they are corresponding. B is equals to E because they are alternate. Right? So F is not in the equation. And we remain with D and G. Where is D? And where is G? Let's see what D is equals to. Boys and girls, let me write here. D is equals to B because they are vertically opposite. D is equals to E because they are corresponding. And then D is equals to G because E is vertically opposite with G. So we can only say that D is equals to G. So the answer is D. Boys and girls, look at the argument and come out with the right answer. That's how we argue. We use the facts. The concept says vertically opposite angles are equal. So you need to master how to locate vertically opposite angles in a diagram. The law says corresponding angles are equal. You need to locate corresponding angles and match them. Then alternate angles are equal. Look for the alternate angles in a diagram. So that's how we were supposed to answer that question. Boys and girls, I hope you do understand. I hope you do understand. Now let's look at 2012 question number 31. Question number 31, 2012. How does it say? Which quadrilateral has all the properties listed below? A quadrilateral is a four-sided figure. A quadrilateral is any four-sided figure. So any four-sided figure is a quadrilateral. And that's why we have regular quadrilaterals and irregular quadrilaterals. Now we have regular quadrilaterals, quadrilaterals that are the rectangles, the squares, the rhombuses, and the parallelograms. So here we only don't have a parallelogram. So you can add a parallelogram as a quadrilateral. Then we have irregular quadrilaterals like the trapezia. This word is a trapezium in singular, but in plural we call it trapezia. Now let's look at these properties, boys and girls. Let us read together. All sides are equal. All angles are right angles. Diagonals are equal. Diagonals bisect each other at right angles. Now look at this. Look at this. We start with square. A square. Yes? Boys and girls? A square has all sides equal. All sides equal. A square, all angles are right angles. Right angles. All angles are right angles. A square, okay, diagonals are equal. Are equal. Diagonals are equal. Do they? Yes, they bisect. Diagonals bisect each other at 90 degrees. Diagonals bisect each other at 90 degrees. So all sides are equal, all angles are right angles, diagonals are equal, they bisect each other at 90 degrees. That is a square. Yeah? Then we come to 2, a rectangle. A rectangle. A rectangle, opposite sides are equal. Are equal. Opposite sides are equal. All angles are right angles. All angles are right angles. Okay, diagonals are unequal. Unequal diagonals. Yes, diagonals bisect each other, but not at right angles. I really need to know. Not at right angles. There's one I forgot about, a square. Diagonals are also angle bisectors. They also bisect angles. Diagonals, they also bisect angles. Now that's a rectangle. All angles are equal, opposite sides are equal. Now let's look at number 3. We'll look at a rhombus. Rhombus is one of the regular quadrilaterals. Rhombus, all sides are equal, opposite angles are equal, opposite angles are equal, diagonals are unequal, but bisect each other at right angles. They are unequal, but they bisect each other at right angles. All sides are equal, opposite sides, like that. Generally, that is a rhombus. Then when you talk about a parallelogram, so we always say a rhombus is an inverted, a tilted square. Let's look at a parallelogram. A parallelogram, like a rectangle, opposite sides equal, opposite sides are equal, opposite angles are equal, angles are equal, opposite angles are equal, diagonals are unequal yeah, so far so good. The others will keep on learning. So which, from this knowledge, I know I've not talked about a trapezium. It's not a regular quadrilateral. It's not a regular quadrilateral. From this knowledge here gathered here, the right answer can only be a square, boys and girls. The right answer can only be a square. So the right answer here is a square. So there are some sums. This sum now gives us knowledge that there are some sums you don't need to calculate. You only need to know facts about them. And so like these properties of quadrilaterals, you would only need to master properties of quadrilaterals to be able to answer that question. Yeah? I hope you have understood. Now let's look at question 17 of Kcpe 2014. Question 17 of Kcpe 2014. The following are properties of a certain quadrilateral. Look at that, is another quadrilateral. Yeah? Opposite sides are parallel. Oh my God, that's a parallelogram and a rhombus. Opposite sides are parallel. I forgot that. Sorry. Those are other characteristics or properties of parallelograms and rhombuses. All sides are equal. Opposite angles are equal. Diagonals are unequal and bisect each other at right angles. That's what brings about the difference between a rhombus and a parallelogram. Right? Then they're asking us, what is the name of the quadrilateral? Again, we are supposed to name the quadrilateral. Boys and girls, it's so clear from this knowledge, we can be able to get the quadrilateral, and that is a rhombus. That is a rhombus. That is a rhombus. Hope you've understood that. Look at this. The Kcpe is able to the sectors of the Kcpe run through the whole syllabus and align some topics. There is what you call a setting grid. So they list the topics and the subtopics and their classes, and name the number of questions that they can come to add up. They can set from the search to add up to 50 questions. There are some questions that are given preference, like geometry is given preference, 4 to 5 questions per paper, 4 to 5 questions per one examination paper, 4 to 5 questions. And I don't know how this is true. My math teacher tells me each question of the geometry would give you 5 marks. Imagine one paper, 5 questions. Each paper, each question, 5 marks. So if you get them all, you have 25 marks already in your pocket from 5 questions. So be very careful. Now, question Kcpe 2013, question 23, talking about the figure PQRS shown below is a parallelogram. So this is a parallelogram. Disregarding this QT, it becomes a parallelogram. Line RST is a straight line. RST, let's look at that. RST is a straight line. Angle STU, let's look at STU. STU is 30 degrees. And angle TUP is 70 degrees. Boys and girls, look at this precaution that I want to give you. As we read such a question, read, understand it, and confirm what you've read from the diagram. Don't just read the question and go into answering. You must verify what you have read from the diagram. So as you read, you check, is it right? Is it indicated? Then you can be able to work out that. What is the size of angle TQR? Let us identify angle TQR. TQR. Where is T? This is TQR. TQR. Angles are identified with the middle letter TQR. Let me write there TQR. So the middle letter is Q. So TQR is the angle between T and R located at Q. T and R located at Q. So that is the angle. That's how we identify the location of an angle. So what is the size of that angle? Now let's go slowly. I want you to look at TQR as a triangle. TQR is also a triangle. Look at triangle TQR. TQR. Triangle TQR. Take it as a triangle. TQR is a triangle. Let me redraw it in red so that you know it's a triangle. That is a triangle. TQR is a triangle. Correct? TQR is a triangle. Can you see it's a triangle? Yes, it's a triangle. So let's now, as we work out the other angles using the properties, angle properties, we will be able to get that. Now, it's very, very now easy to know this, yeah? Boys and girls. Let's look at the clues that would lead us into getting that. 70 and 70 and this angle here. 70 and this angle here. This angle is TUS. 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 70 and TUS are angles on a straight line. Which is the straight line? PUS is the straight line. So 70 degrees and TUS are angles on a straight line. Boys and girls, you know very well that angles on a straight line add up to 180 degrees. Angles on a straight line. I'm the space to work out this. So angles on a straight line. Here I want to work out here from here. So angles on a straight line add up to 180 degrees. That means angle TUS plus 70 degrees will give us 180 degrees, boys and girls. Do understand? Are we together? Now, we take 70 the other side, becomes minus 70. So TUS is equal to 180 minus 70. That gives us to 110 degrees. That is 110 degrees, yeah? Are we together? 110 degrees. So TUS is 110 degrees. We would still get the same 110 degrees here, boys and girls. Now look at 110 here and 110 there. They are opposite, isn't it? True, it is, they are opposite. Still, this 110 and 70 are angles on a straight line, boys and girls. That's point number one, leading us the right direction. Now, putting in mind that this RST is an extension of a parallel line. QP and RS are parallel lines, and QT is a transversal line. Look at that, boys and girls. QP and RS are parallel lines, and QT is a transversal line. That's a transversal line. Let me write it here. Transversal. It's a transversal line, boys and girls. Yeah, joining these two parallel lines. This angle 30 looks at that angle as an alternate angle. That only tells us this angle here is 30 degrees. Boys and girls, that's 30 degrees. That's 30 degrees. All right. Are we together? That's 30 degrees. Now that only will tell us that if this is 30 and that one is 110, this small triangle here, it's still a triangle whose angles add up to 180 degrees. Angles in a triangle add up to 180 degrees. So it's possible to get that angle, isn't it, boys and girls? Give it a name X. Allow me to work out here, from here, that X plus 30 degrees plus 110 degrees should give us 180 degrees. All right. Understand that? So X plus the sum of 30 and 110, 140 degrees should give us 180 degrees. Understand that? Now we transfer 140 to the other side, becomes minus 140. And so that makes X to become 40 degrees. Look at that. So the value of X there is 40 degrees. So this is 40 degrees, boys and girls. Are we there now? Do you understand that? Now we are told that PQRS shown below is a parallelogram. Let's come to the properties of a parallelogram. Opposite angles are equal. So this QPS is opposite to QRS. So that angle is also 40 degrees, boys and girls. Put in mind the angle that we are looking for. We are almost there, boys and girls. So this is the angle we are looking for. That is the angle we are looking for. TQR. Now, in this triangle, TQR, we already have 30 degrees and we have 40 degrees. We are remaining with angle Y. That's what we are looking for. Angle Y. So boys and girls, I'm looking for a suitable place to work out that. Now, let me do it from here. Angle Y. We take Y, we add 30 degrees, we add 40 degrees, we say it's equals to 180 degrees because angles in a triangle give us 180 degrees as a sum. The sum total of angles in a triangle is 180 degrees. Boys and girls, look here. So Y plus the sum of 30 and 40, which is 70 degrees, should give us 180 degrees. Boys and girls, we transfer 7 to the other side and subtract it from 180. That means Y is equals to 110 degrees. Angle Y is 110 degrees. So our answer here is 110 degrees. And that is the right angle, and the right answer, boys and girls. 110 degrees. Choice B. Look at the journey that we have traveled together, boys and girls. We are using properties, angle properties, to solve these questions here. To find angles that we have not been given their measurements. We are working on properties. We're using properties to get those angles. I would want you to try some questions, boys and girls. 2010, Kcpe 2010. Please try this, Kcpe 2010. Try this. I don't want to, okay, this is repeated. Kcpe 2010. Question 7 and 19. Question 7 and 19. Kcpe 2009. Question 5. Kcpe 2011. Question 20 and 41. Hope you're taking notes and you are able to. Kcpe 2015. Question 36. Question 36. 2016. Question 19 and 41. I want to go to 2018. That was 2017. Question 47 and 36. Don't you worry about the jumbling. And then 2018. Question 18 and 48. And finally 2019. Let's see which question in 2019. 2019, question 27 and 36. I hope that will give you enough practice on such. That is geometry part 1. We will have to do part 2 to complete geometry, boys and girls. I am so glad that I have taught you, and I know I have taken a long time. Yes, but it was for a good cause. I will always endeavor to teach you what comes in my mind according to Kcpe. I will always be there for you, boys and girls. Have a lovely evening. Bye-bye.